Hey everybody, sorry about taking so long to get this video to you. The first video that I attempted to record, I put it onto YouTube and then there was no audio with it. So I'm going to be trying again. Hopefully this time it works a lot better. So in term 3, we are going to be starting with similar figures and similar triangles. And so the first thing that we're going to start with is doing dilations. So we're going to take care of these first 2 points here, where we're just going to be learning how to do a dilation. To be honest, the other 3 down below, I know that you're going to have a lot of work from your other classes, and so just to kind of help you out, I'm thinking that we're going to skip that, and instead what we'll do is we'll move into section 2 and section 3 then in the next video. So the first thing with a dilation is we need to remember what that is. So you should have learned about dilations back in your middle school, and I believe IM1 also covered this. So a dilation then is going to be a transformation that maps some point P to the image, and we say this is P prime. And it's going to have some center O and a scale factor of K. And so the scale factor is going to make the shape bigger or smaller. So as you can see in the picture, we have this triangle ABC, which is going to get mapped then to triangle A prime, B prime, C prime. Now we do have special names for these as well. The first one is the pre-image. And so a pre-image is going to be the original shape before we do the dilation. And then the second shape, the result, that is called the image. So A prime, B prime, C prime is the image, and ABC is the pre-image. So in this first example, we are going to take a line segment that connects the points A and B, and we are going to dilate that by a factor of 3 centered at the origin. So what we should do is we should go ahead and make our points. So there is point A, and then there is point B. And I'm going to go ahead and label them as well. And it's supposed to be a segment connecting the two. So like that. Then what we're going to do is we're going to dilate it by a factor of 3. So all we have to do is we have to take the values from our coordinates and we're going to multiply those by 3. So the point A at 1, 2 is going to get mapped to A prime by multiplying both of them by 3. That's going to give us a point at 3, 6. So that will then go, I'm going to draw in blue. 3, 6 is right. Oh, I'm sorry, I drew the wrong point for A there. We have 1, 2 and 3, 1. I'm sorry, I had those switched around. Okay, so there we go. So there is where AB is supposed to be located, and then for A prime, 3, 6 is located up there. Then we have to do the same thing for point B, and we have to find B prime. So we're going to start with 3, 1. We multiply both of those by 3. That's going to give us then B prime located at 9, 3. So then if we find that on our graph, there we go, that's where B prime is located, and I can connect the two, and there is the image. And we were supposed to find the coordinates for A prime and B prime. There they are. So an important thing that we need to be aware of, these are the exact same line segments that we had in the previous example. They are going to have the same slope. And whenever we have the same slope, that means that they are going to be parallel. And I can demonstrate this because for the first one, it goes down 1 and it goes to the right 2. So we know for the first one, down 1 to the right 2, that's a slope of -1/2. And then for the second one, we see that it's going to be down 3 and right 6. And that also is going to simplify to be negative 1/2. So an important thing for us to remember is that whenever we dilate a line or a segment, it will always have the same slope. All right, for this question, I want you to attempt this on your own and then pause the video. Once you are done, start the video again and I will show you how to do it. Okay, now that you have given this a shot, I'm going to demonstrate how to do this question. So, preferably, you're going to do this without finding a prime b prime, especially since that scale factor there does not look nice. So what we're going to do instead is we're going to find the slope of AB. So if we're going to do the slope of AB, we know then that with our points right there, we're going to do 4 minus 3 over, and then it's going to be negative 1 minus negative 2. And when we simplify, we know that the top is going to be 1. Down on the bottom, negative 1, that becomes plus 2. So that becomes 1 as well. And we see the slope is 1. And therefore, that is going to be the same slope for a prime b prime as well. So there is the answer for part A. Now, before we get into any of the other parts then for that question, I just wanted to remind you of the distance formula. So this is something that was covered back in IM1, and it's going to be the distance between x1, y1, and x2, y2 that can be found with this equation right here. Now, I will admit that equation looks kind of intimidating. It's a little complicated, it's a little hard to remember. But the good news, if you ever forget it, the distance formula is really just a simplified form of the Pythagorean theorem. Because Pythagorean theorem normally is going to be a squared plus b squared equals c squared. Well, if we happen to do the square root of both sides, square root of a squared plus b squared equals c, we can see that this c corresponds to the distance d, and then the square root of a squared plus b squared is the same thing as the square root up here at the top. So if you ever forget the distance formula, I highly recommend that you just think of Pythagorean theorem instead. And in fact, for some of the next couple of questions, I'm going to demonstrate how to solve them using both formulas. So before you try it on your own, I'm going to demonstrate how we can get the distance between point C and D by using either the distance formula or the Pythagorean theorem. By the way, just so you know, if you are asked to find the distance, sometimes, not the line, but sometimes you're going to be asked then to find CD, and it's up to you to know that means that you're supposed to find the distance. So for the first one, we're going to use the distance formula. So we're going to have D equals, and the equation said that we were going to have to find the difference between the two x values. Now it doesn't matter which one we start with, so I'm going to just take negative 2 first, and we have to subtract the other values. So negative 2 minus 2 is the first part. Then we have to square that. We're going to add, and now we have to subtract the two y values. 4 minus negative 6. And then we're going to also square that. Now we just need to simplify the inside. Negative 2 minus 2 is going to be negative 4. 4 minus negative 6, that's going to turn into 10. Now we have the square root of 16 plus 100, and we get square root of 116. By the way, we should be writing our answer in simplest radical form. So even though we have the square root of 116, we should try to reduce that into something smaller. And just by looking at that, I can tell that that number is going to be divisible by 4. I know that if we had 120, we could definitely divide that by 4. So 116 is also divisible by 4 since it's 4 away from 120. So I'm going to split this up. D equals square root of 4 times the square root. And whatever that number is, well, back for 120, 120 divided by 4 is 30. We're 1/4 away from 120, so it looks like that's supposed to be 29. I'm going to double check with my calculator, and I did get 4 times 29 is 116, so that is correct. And then the last part is we can simplify square root of 4 into 2, and then that part stays square root 29. So there is the distance between the 2 points. Now I'm going to show you how to do this with the Pythagorean theorem instead. And this other way, what you should do is you can graph these 2 points and then use your graph to help you determine the distance between them. So C is up there, and then for D is all the way down there. Then we are going to find the distance. So I see to go from C to D, we have to go to the right 4. And to go down, if we count that all the way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that was a distance there of -10. So if we put this into the Pythagorean theorem, if we draw in the hypotenuse there, the hypotenuse was c squared. A squared, it doesn't really matter which one we choose, so I'm just going to say it's 4. And then we have to do b squared, which is -10 squared. We simplify, we get c squared equals 16 plus 100. C squared equals 116. And you can notice that we end up with the exact same value. C equals square root of 116, which we know will simplify into 2 times the square root of 29. So again, use whichever method is easiest for you in order to find the distance between 2 points. Now that you've seen how to do that, go ahead, pause the video, and I want you to attempt B and C. When you are done, start the video again, and then I'll demonstrate how to do these. All right, once again, we want to try to find the answer for B without using this scale factor, because again, the square root of 2 is not really pleasant to use. So if we want to find the length, I'm going to choose to do this with the Pythagorean theorem way. So we have to find where -2, 3 is. There's point A. And then where B is, 1, 4. Oh, so those are actually pretty close. So I'm going to make a better graph. So there's point B, and then here is point A. We can see that triangle is really small, but it was going to be down 1 and over 1. And we're trying to find then the hypotenuse. So that will be c squared equals -1 squared plus -1 squared. And then we will get, let's see, c squared equals 1 plus 1. And sorry, that shouldn't be c squared anymore. That should be c equals the square root of 2. Now, we do have to be careful though, because this c value that we just found, this is the distance, but that's for AB. We were asked to find this for the image of AB. So for A prime, B prime, well, we figured out now that, sorry about that, we figured out that the hypotenuse is the square root of 2. So we just need to take our answer, square root of 2, and then multiply it by the scale factor to find the new length. So if we do square root of 2 times the square root of 2, well, that becomes square root of 4. and therefore the length of the image A prime B prime is going to be 2. Then for this last part, what are the coordinates of the images of A and B under D? Well, we just need to do A times square root of 2. There's no way we can really simplify it, so we're just going to keep it negative 2 square root 2 and 3 root 2. And then for B, same thing. There's not really much simplifying we can do. So if we multiply that by the square root of 2, B prime is going to be negative square root of 2 and 4 root 2. Okay, as a reminder, we need to know the meaning of the word collinear. And so that tells us that the points can be connected by one line. And then also, any 2 points are always going to have the same slope. So like in the picture here, we can see AB and BC should have the same slope, as should the entire part AC. So for part A, it says we are supposed to construct A prime, B prime, and C prime, which is going to be the images, I should say, for A, B, and C, and we're going to do it with a scale factor of 2. So since I'm doing this on my iPad, I can cheat a little bit. I can go ahead and draw in a line segment that connects I to A. Because if we have that length, the image is supposed to be twice as far from I. So I can go ahead and draw it right there, and that gives me where the image is located. That is A prime. Now I'm going to do the same thing with B. I'm going to draw in the line segment. And then I'll paste it. Because it was supposed to be a dilation of 2, scale factor 2, so that means it's supposed to be twice as far. And there is the location for B prime. And my last one is going to be for C. Scale factor of 2 tells me to double the length. There we go. And there is C prime. So that takes care of part A. So the second part, measure A prime, B prime, and then A prime, C prime, and we're supposed to compare it to the measures of AB and AC. Well, we were told originally that AB was going to be 1, and we were told that BC was going to be 2. So what I'm going to do, once again, is cheat a little bit. I'm going to use this to measure. And if we can get those, if we can get an even number of those to fit inside, there's one, there's a second one, and how about that? It turns out that the length A prime, B prime ends up being twice as long as AB. And what's going to happen is that the exact same thing then is going to occur for BC. So if we have that right there, we know that that was 2. Because the scale factor was 2, this should be twice as long. And indeed, when we connect those, we can see that we get a length of 4 for B prime, C prime, whereas BC was a length of 2. So that also... B prime, C prime is also twice as long as BC. And then lastly, part C, does the drawing support the fact that the images of the collinear points A, B, and C are also collinear? Well, as we can see right there, A prime, B prime, and C prime all appear to be in a straight line. It's not perfect, but it's supposed to be a straight line. So for part C, yes. Okay. Now, In my original video, I did do this as well. As you can see though, there are a lot of points. So rather than demonstrate how to do the entire thing, I'm only going to do it with just a couple. So I'm thinking that I'll start with S to B. And I think I will also do, how about S to C? And I promise you that if I were to do this with all the other points, we would get the exact same shape, just dilated for all the lengths to be twice as big. But that's going to take a lot of time. So I'm just going to demonstrate here first with point B. And that brings us to where B prime would have been. And hopefully you can agree with me that SB prime is going to be twice as long as SB. Likewise, if we do the same thing with the segment that connects S and C, and we double that, there's C prime. The scale factor is a 2. SC prime is twice as long as SC. Okay. Once again, I want you to pause the video and attempt these two questions. When you are done, then you can start playing again and I will demonstrate how to solve it. Okay, now that you are done, oops, sorry about that. Now that you are done, what you should have is, you should have drawn the 3 points. So there's -3, 0 for A. B is 0, -6. C is 1, -8. So there's the 3. We're supposed to verify that these are collinear. So again, earlier I had shown you that if they are collinear, they are supposed to have the same slope. So I'm going to go ahead and I'm going to just connect A, B, and C. Well, I suppose that gives away that they are collinear. But what was supposed to happen is that for your slopes, going from A to B, that's going to be down 6, and that's going to be to the right 3. And we know that -6/3 simplifies to become -2. And then for the other part, that was going to be, it's a little bit tough for me to fit that in there, but there was going across 1, and we went down -2. And of course, -2/1 also becomes -2. So the slopes were the same for AB and BC. Therefore, all 3 points have to be on the same line. Okay, then the next part is that we're supposed to find the images A prime, B prime, and C prime if we do a scale factor of 1/3. So this is going to get a little tight in this picture here, but we're going to do our best. So A was -3, 0. If we multiply that by -1/3, then A prime is going to be located at -1, 0. So there's A prime. Oops. There's A prime. B, 0, -6 times 1/3, that's going to get you 0, -2. And then the last part for C is that this one's not as nice for us. Oh, I did 1/2 there. But we're going to get 1/3, and we get -8/3, which is the same thing as -2 and 2/3. So the other points, that's where B prime is going to be located. And then for C prime, as we said, 1/3 and about 2 2/3. It's about, I'm doing my best, but that's going to have to be good enough. That's roughly where C prime is. So I went ahead and I plotted all the points then onto this graph. Same thing, go ahead, try these questions, pause the video. When you are done, play it, and then I will show you how to solve it. Okay, now that you are done, so the easy part for showing that these are collinear is going from A to B, because that's just going to be down 2 and over 1. and we know that that simplifies to be a slope of -2. Then we have to verify that b prime and c prime are going to be collinear because they have the same slope. And for that one, we need to see that we are going to go down. So it might be helpful if we had the coordinates here. B prime, as a reminder, was going to be 0, -2. C prime was 1/3 and -8/3. And I think it may be easier for us if we actually calculate the slope. So if we take 8/3 and I'm going to change -2 into 6/3. And then for the bottom we can keep 1/3 minus 0. That's going to give us then, let's see, -2/3 over 1/3. And a neat little trick here is that because the denominators in the top and bottom are the same, those cancel. We are going to get -2 over 1, and yes, we get -2, so those 3 points are indeed collinear because A prime, B prime, and B prime, C prime have the same slope. Then the last part, compare A prime, B prime to AB. Remember that this here is telling us to find the lengths. So if we are supposed to find the length of AB, we know that we are going down 6 and we're going to the right 3. So we're going to have to use Pythagorean Theorem there. We're going to get c squared is equal to 36 plus 9. We get 45. And we can simplify that then into square root of 9 and square root of 5. So we know that the length of AB is going to be 3 root 5. Now, do you have any guesses as to what the length is going to be for A prime, B prime? Well, we could either calculate it by using the picture, or another thing that we could do is we could just use the scale factor. I'm going to go ahead and use the picture to help us figure it out, and I think you'll be able to confirm your guess when we get our answer. So we saw that to go from A prime to B prime, it was down 2 and right 1. So if we go ahead and solve for C, we are going to get 4 plus 1. We are going to get C equals the square root of 5. And what you should have spotted is to go from 3 root 5 to root 5, it ends up that it's the same as our scale factor of 1/3. So hopefully that's what your guess was, and that's going to be the relationship then between those two lengths thanks to our scale factor. All right, everybody, you made it through the first video. So here is the assignment. Just be aware that on Schoology, I have told you you can skip some of these questions. So make sure to take a look at that so you don't end up doing the entire assignment if you are somebody who was not interested in doing that. So thank you for listening.